Hi, I am Zachary Kircher, and this is a combination of tutorial 9, 11, and 17 for my GHS Electrical Engineering class 2025. This is a combination because the components I will be using exceed more than one tutorial. Moving on, in this tutorial, I'll be using the following components: a potentiometer dial, which is a variable resistor you can turn to limit or increase the allowed flow of electrons. A SPDT, or single pole double throw switch, which works by having the common attached to the input on the board, and the two poles connected to ground and power. Depending on the position of the switch is which way the circuit will be connected. One way it will connect to ground, and nothing will happen because it will be reading a 0 or off. When it's connected to power, however, it will be receiving a 1 signal or on. We will also be using a piezo, which works by converting electrical energy into vibrations, which produce sound. This sound, through code, can be changed to play at different pitches or lengths. The largest component in this circuit is the LCD display, which is a display that works by lighting up certain pixels on a 16 by 2 grid, meaning 2 rows of 16 boxes. Of course, there is also the necessary resistors in place, particularly 4 220 ohm resistors, in order to protect our components from the flow of the electrons. And finally, we will be using the STEMterra board, which combines a solderless breadboard with an Arduino R3. To start off, we will be taking a look at the schematic for this circuit. As you can see, we have the various schematic symbols for the parts as I mentioned previously. Here are the 4 resistors, the potentiometer, the piezo, the single pole double throw switch, the Arduino R3, and the LCD. Here you can see the line of 5 volts which connects to the LCD and the switch. You can also see the line coming back to ground, which is connected to every component. Starting off with the LCD, you can see the VCC pin, which is connected to 5 volts, the D7 pin to digital 2, the D6 pin to digital 6, the digital D5 to digital 4, and the D4 to digital 5. The state of these 7 to 5 data pins, high or low, are the bits that you are writing to a register when you write or read the values of the LCD. The RS pin is connected to digital pin 12, which controls where in the LCD memory you're writing data to. You can select either the data register, which holds what goes on the screen, or an instruction register, which is where the LCD's controller looks for instructions on what to do next. The read-write pin is connected to ground, which selects reading or writing mode. Then there's the enable pin, which connects to digital 11, and then there's the VDD, which is connected to ground, the VO, which is connected to the output of the potentiometer, and it controls the dimness of the screen. And finally, the LED plus connected to 5 volts here, and the LED minus connected to ground. These control the LCD LED backlight. And over here is the potentiometer, which is connected to power and ground. Piezo is connected to digital input 3 and ground. And then the single pole double throw, which is connected from power and ground and digital input 8. Next, we will be looking at the physical circuit. Here you can see the 4 resistors, the piezo, the single pole double throw switch, the potentiometer. The Arduino, however, is built into this breadboard, as I explained. And finally, the LCD. You can see the various wirings across the board, and as we turn it on, you can see that coins will print across the screen and the Super Mario theme song will begin to play. And if I switch this and reset the board, which was necessary given it would have to run through all this code and then read the switch. So for a quick switch, we just hit the reset button, and as you can see, the Pirates of the Caribbean theme song starts to play. And that's it. Finally, we will be taking a look at the code for this tutorial. This first section is the code I found for the Pirates of the Caribbean theme song, the link to which will be in the description. Here it defines the pins for the buzzer and the switcher, which I wrote, and this is all part of the code where it defines the notes, it defines the melody, which basically dictates which notes play in which order. It defines the tempo. This is for the Mario. I will put the link for that in the description. Here you again have the order of the notes in which it plays, the duration of the notes. Getting down here is code I wrote. This is the library for the LCD. And these two pieces of code are what I used to create the skull and the coins in the LCD display. You do this by picking the specific pixels to light up in in one of the 16 squares. And then down here you can see these are the different pins for the LCD. This is the switch state, which allows me to check the last state of the switch. Here in void setup, you have the variables for the skull and coin, which will allow us to call for it later when we print. You have the input and the output for the switch and the buzzer. You also have the piece of the code that tells the serial monitor to begin printing. Here we have a variable for the switcher value, which will be compared to the last state of the switch. And we also have the LCD begin code, which is the 16, again, the 16 pixels by 2 rows, and an LCD clear, which will clear it before it begins to run any of the code below. Down here in void loop, we have, again, another code checking the switcher value. And if the switcher is equal to 1, it will clear the LCD, print Pirates of the Caribbean on the first line, set the cursor to the line below, and print the Caribbeans on that line. Then we'll set the cursor to the second square on the LCD on the first row. And then we will write the byte 0, which, if you recall, is the skull. Then we will set the cursor to the opposite side and again call it. And then this is all code for the music, calling back to what was stated above. And next, if the switcher state is 0, it will again clear the LCD, print super on the middle of the first row, then it will set it to the line below and print Mario in the middle. And here's how I printed the code, and it works similar to the skull, and I use these delays to print them in a wave, as you saw. So this prints the first 2 coins, it delays by 1/4 of a second, and then it prints the next wave, again, the 3rd wave, 4th wave, 5th wave, and the 6th wave. These 3 sings are the actual song. They are a variable that is defined below, and that is the end of if switcher equals 0. There is also, now here are the int value, the variables for the songs. This is sing, and This is for the Underworld theme. Here is the ints for the Mario theme song, and that is the end of the code. That is the end of my tutorial 9, 11, and 17 video for GHS Electrical Engineering 2025.